Very good morning, everyone, guys. Very good morning, everyone. So we are going to start discussion on the oxidizing agents. It's a very important topic. And yes, please once confirm if you can hear me properly. We are going to quickly start. Yes, all good. Very good morning. Very good morning, everyone. All right. So this is a revision series basically, and we are just going to quickly start the uh, you know doing the reactions. We'll see few examples. Yes. All right. Very good morning. Yes, very good morning, everyone. Once again, chalo. Let's begin the discussion. So, before moving onwards, let me quickly remind you all that, guys, there are two important batches going on Unacademy Plus, as you already know. So, one is the Impulse Detailed Batch course, as you can see over here. And in this, we are completing all the important topics, theory topics, basically concept and theory for the chemical sciences, all the topics of inorganic, organic, and physical chemistry. Same over here, we are doing practice of all the same important topics. Okay, so these important courses are made for your syllabus completion and practice. Also, guys, we are having a very important All India mock test. All India mock test, which is curated by Unacademy educators for all of you, and the test is free for everyone. So what you are going to do is the test is for life science, chemical science, and mathematical sciences. The date is 28th of August, and you also have some really good prizes for the first three rank. Okay, so what you're going to do is you're going to enroll in the test, and you have to do is enroll and give the test. Be present on 28th. The test is from 10 a.m. in the morning. All right, very important. This is yes, guys, your very important chance to analyze your preparation from all very important questions. You might get some really important, new questions also from here, right? So do attend this session, right? This test. Also, guys, if you want to get further notifications of all the classes, join my Telegram group CSINet 2022. All right? Yes. Chalo. So let's start our discussion. Hello, good morning, everyone. Yes, guys, let's start the discussion. So first of all, guys, we are going to study the. It's a very important reaction. It has been asked in GATE, CSI, and NET, TIFR examination, BARC examination. Everywhere it has been asked. Very important. Swan oxidation. All right. So first of all, guys, we are going to do all the non-metal oxidation because I think metal oxidation we already have a little idea about. We are going to that is why start with the non-metal oxidation. Okay. So let's quickly revise, guys. What is the Swan oxidation? What is the reagent that the Swan oxidation is using? Who can tell me this? Yes, guys, who can tell me this? What is the reagent used over here? Let's say I'm having a ketone. Then there is some popular reagent used for Swan oxidation. That ketone is going to be, or let's say the alcohol is going to be oxidized into the ketone. Okay? Yes, so this is your alcohol. It's going to be oxidized into aldehyde in this way. Alright, so what is the reagent that we are using over here in the Swan oxidation? We use, it's a very popular reagent, absolutely Ria, DMSO, very good, DMSO plus oxalyl chloride. Yes, oxalyl chloride, COCl whole 2. तो बहुत ही popular combination है guys. So if you know in the reaction DMSO is given in COCl whole twice, this is known as oxalyl chloride. If this is given, you will understand it is Swan oxidation. And there are two important questions on Swan oxidation. That is, if we are doing complete Swan oxidation, or let's say if we are not doing complete Swan oxidation. So in both the scenarios, what is going to be the product? ठीक है, तो पहले हम करते हैं complete Swan oxidation. Yes, guys, let's look at the mechanism. So what is the DMSO going to do basically? Let's say this is your DMSO, MES double bond O, and one more methyl. So in the presence of oxalyl chloride, what it does is just the formation of the electrophile is required over here. Yes, let's see what's happening. So the sulfur, yes, over here, the sulfur is going to make this oxygen attack on this carbonyl carbon, which has a good leaving group, which is the chloride. All right, and then you have something like this. Positive charge on sulfur, double bond O, one double bond O, or you get Cl. So one Cl minus is free from here, isn't it? What is this Cl minus going to do? ये क्या करेगा? It's going to attack back on this sulfur, and this whole is a good leaving group now. All of this is a good leaving group. Yes, you are going to ultimately get MES, MECl plus one molecule of CO2 eliminated from here. Yes or no? Plus one carbon monoxide plus one more Cl minus is free. Yes. So this much is understood to everyone. Yes or no? Quickly tell me, guys. Swan oxidation, DMSO plus COCl2. We are doing the mechanism. Yes, DMSO and COCl2, they are first of all going to react with themselves. And what is the purpose? The whole purpose is to generate this electrophile that you see. What is this electrophile known as, guys? इसका क्या नाम है? इसका नाम है क्लोरो dimethyl sulfonium ion, isn't it? Chloro dimethyl sulfonium ion. Yes, and what is this? This is an electrophile. And now what is going to happen with the alcohol? So the alcohol is going to attack over the sulfur like this and eliminate Cl minus. What does it give you? Let's see. Yes, what does it give you? Alcohol will now attack. All right, let's say there's a sulfur, both, both the methyls over here, two hydrogens. Now in the second step, guys, see what happens is this step is done at a very low temperature. Yes, the formation of chloroiminium ion, chlorosulfonium ion, this is done at minus 78 degrees centigrade. Alright, so the first step of Swan oxidation. Swan oxidation is a two-step reaction. First step of Swan oxidation is done at minus 78 degrees centigrade, and then in the next step, then we are adding triethylamine, which is a good base. Alright, you know that it's a good base. What is the base going to do? Very, very important. We are going to look at this in the next step. Now guys, something really important is that when you are doing the next step, that is the addition of a base, you have to take the temperature from minus 78 to, let's say, room temperature. तो उस पे लिखा होता है comma करके warm. So you are warming. But what is warming, guys? In this particular reaction, taking minus 78 degrees centigrade to 0 degrees centigrade. This is warming. This is known as warming, okay, for this particular reaction, right? So guys, let's see what happens when you are taking the base in the next step. Yes, we are going to quickly see the mechanism and then we will see the examples, guys. So yes, what have we got over here? We have got the methyl. Let's say I'm writing this methyl as CH2H, sulfur has a positive charge. Now guys, you might get confused कि मैम ये वाले प्रोटॉन ज्यादा एसिडिक है कि ये वाले प्रोटॉन ज्यादा एसिडिक है, which proton is more acidic, so that the triethylamine is going to remove that proton. So definitely guys, this methyl is connected to sulfur, which has a positive charge and which is also connected to the electronegative oxygen. So absolutely the ethylamine is going to remove this proton from here, and the reaction will proceed in this way. Be very, very careful of what is happening over here. Let me also tell you कि आप कहाँ mistake कर सकते हो. CH2 minus है, ठीक है? So now this CH2 minus is going to remove a proton from here. Bond falls up on the oxygen and the DMS is removed. What is the byproduct, guys? What is the byproduct? Dimethyl sulfide, which is also sometimes directly written as DMS, dimethyl sulfide. This is the byproduct. ठीक है, आप गलती कहाँ कर सकते हो? that is, in the presence of base, you might remove this proton accidentally and then directly eliminate in this way, but don't do that. It's not correct. Triethylamine is not going to remove this proton. Okay? Yes. This mechanism is wrong. जो ऊपर लिखा है वो ही सही है. Alright, I just hope that you understand the mechanism. Now guys, the most important thing, the questions have already been asked on this thing कि अगर हमारे पास second step नहीं है, let's say we are not doing the second step, you only have an alcohol, DMSO, COCl2 combination at -78 या फिर -60 degree centigrade, whatever could be given. ये हो गया first step. Second step में I am not adding the base, I am only warming. Then what does it give you? You know that it's going to give you the chlorosulfonium ion in this way. Same है पूरा का पूरा, right? So in this case, if you are not providing the triethylamine, what would happen? There is a free Cl minus which is moving around in the solution. Yes, so that Cl minus is going to do nucleophilic attack, and you will not have the oxidation, you will just have the conversion to chloride. Okay, followed by DMSO regenerated. DMSO is regenerated. Okay. So very important guys. This is a very important implication of this reaction. Let's say if you are not providing base, then what will happen? Alright. Very important. Okay. So we must provide base in the second step to complete this reaction. Alright. चलो अब एक इसका question करते हैं. Let's see how it can be used, how this concept could be used. Okay. Yes, let's see that. So example number 1, let's say we have this molecule. Good morning guys, good morning. We have just studied swan oxidation. So we have COCl whole twice, oxalyl chloride and DMSO, and -78 degree centigrade, and in the next step you are having triethylamine. So yes, what is going to happen now? Is it going to selectively oxidize, or it is going to oxidize both of them? Yes, everyone. Both. Absolutely, it's going to oxidize both of them, and both of these are going to give you the ketones in this way. Both of them, see, this is a ketone, this is an aldehyde. Now let's say I am doing some other reaction on this molecule. Let's say I'm providing you PH3P double bond CHCO2 Me. मैंने ये provide कर दिया. What is this? Ylide. Then which of these two group is going to react, the ketone or the aldehyde? Which one will react, and what will be the stereochemistry of the product? Yes, what is the stereochemistry of the product? Absolutely guys, you are going to react the more reactive carbonyl. Which is a more reactive carbonyl? Aldehyde is the more reactive, isn't it? So aldehyde react karega na? And then what is the stereochemistry? It is absolutely trans. Why? Because you have a stable ylide, no? So this is the molecule that you get. E-alkene. Very good. E product. Very good. Alright. Very good guys. So ठीक है, ये आपने कर लिया crack. Very important. Very good. Now second thing is, let's say I am having an amide. क्योंकि usually you see the swan oxidation, we usually see this on the alcohols to convert them into aldehyde or ketone. लेकिन मैंने amide ले लिया. ठीक है. and I'm providing the same reagent, COCl whole twice, oxalyl chloride, and DMSO, and let's say minus 60 degrees centigrade. तो क्या बनेगा guys? Also, I'm taking the base in the next step, triethylamine. Same thing I'm doing with the amide. So क्या बनना चाहिए? Ketone. Yes, is it supposed to make the ketone or something else? So this combination is very beautiful. Also, guys, you must remember the Wills-Meyer-Hack reaction where you were taking something similar, not exactly the same. वहाँ पे आप क्या ले रहे थे? POCl3 ले रहे थे. POCl3, isn't it? Yes. So what was the role of that? What is the role of COCl2, guys? इनका role है to make the oxygen a good leaving group. Yes. To make the oxygen a good leaving group. It is doing the same with DMSO. Yes. तो अब हम क्या करेंगे? Making the oxygen a good leaving group can be done by the same thing. ये देखो. You have the you have the amide for example, or let's say हमें यहाँ पे क्या चाहिए? We need this thing, dimethyl sulfonium chloride. Yes. So from this combination we'll get the same thing, right? ये ऐसे push कर देगा इसको, isn't it? You have our oxygen, sulfur, and a positive charge over here. You have NH2 and you have a Cl minus also. Now guys, you are having the same choice that you are having a base in the next step. Base किसका proton eliminate करेगा? The methyl proton or the NH2 proton? The methyl proton or the NH2 proton? Absolutely the NH2 proton, isn't it? It is more acidic than the methyl proton now, even if the methyl is connected with the sulfur. Amine ka proton, absolutely. So let's say it has removed this proton from the amine and let's say it has become NH now. Yes. Alright, very good. So the triethylamine can remove one more proton from this so that the oxygen completely eliminates and you completely get the nitrile. So this is another application of this reagent of the Swern oxidation. ठीक है? इसको हम Swern oxidation नहीं बोलेंगे guys. Why? Because the reaction is different from what we have been doing in oxidation, but it is the same use of Swern reagent for the oxidation of primary amide into cyanide. Very 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 important. ठीक है? अच्छा, चलो. So we'll see one more application. अगर हमारे पास एक molecule में, yes, let's say in one molecule we are having three different groups like this. There are two OH groups and then there is a amide also. Primary amide. See, absolutely I think it makes sense to you that we need a primary amide. एक substituted amide होने से नहीं होगा reaction. Why? Because we need to eliminate these two hydrogens, right? So yes, very important. So we are doing the same thing, guys. We have DMSO, we have COCl whole twice, minus 60 degree centigrade oxalyl chloride, और फिर next step के अंदर then triethylamine. What is going to happen? Any selectivity or something? Yes, Kajal, I'm good, thank you. Good morning, Tasneem. Welcome all of you guys. So we have studied the Swan oxidations. Yes, guys, tell me what's going to happen in this molecule. All right, yes, very important. So, absolutely, देखो, there will be no selectivity when you are doing this reaction. It is completely going to be giving you this product. So, there will be a diketone in this way and the nitrile as it is. Okay, so this is the final product of the Swan oxidation of this particular molecule, right? But be careful, we only need a primary amide for this. Other amides are not required. Okay? Yes. So let's try out one more reaction which is similar to this, guys. बहुत ज़्यादा similar है इससे. What is that? Let's see. Yes, we have Corey-Kim oxidation. All right. We have Corey-Kim oxidation, and it is very similar to Swan oxidation. कैसे? Let's see. So you are having the same alcohol. Let's say you are having the same primary alcohol, for example. ठीक है, इसमें हमने क्या प्रोवाइड किया? N chlorosuccinimide and DMS, not DMSO. We are providing only DMS और फिर वही then triethyl amine. So basically, guys, we are doing the same thing just like your simple स्वर्ण ऑक्सीडेशन, बट हमने थोड़ा सा चेंज किया है, DMSO नहीं लेके DMS लिया है. All right, so only a little bit of difference. All right, so let's see what's happening. Yes, so ultimately, guys, इसका गोल क्या है? गोल तो वही है, to remove this, to make this proton leave, and sulfur is going to take away the electron density. So we just want to make the chloroiminium ion. Can we do it by some other mechanism? Let's try out. This is going to give you the same aldehyde. इसका mechanism check करते हैं. Let's see what's happening. Let's check the mechanism for this. So you have N chlorosuccinimide and you had DMS, मतलब कि dimethyl sulfide ऐसे करके. So dimethyl sulfide, can it attack on this chlorine and can the electron density push over to nitrogen? हो सकता है ना ऐसे? Why not? Because nitrogen के पास दो carbonyl है, two carbonyls on nitrogen. Yes, guys, two carbonyls on nitrogen. So, is it easy? Yes. Is this reaction very simple? Very similar to Swan oxidation? All right. चलो. So yes, बहुत ज़्यादा similar mechanism है, guys. Just what we have been doing to the Swan oxidation. You have got the chloroiminium ion just by a different method. And what is going to happen now? The same thing, the absolute same thing. You are having two hydrogens in this way. ये क्या करेगा? It's going to attack on sulfur like this. Chloride is removed और ये बन गया आपका chlorosulfonium ion, which is going to lose a proton in the exact same way, because then you have the same base, then triethylamine. So exactly the same thing, guys. So let's say if Swan oxidation is asked, you have oxalyl chloride and DMSO. वो एक दूसरे तरीके से ये same chlorosulfonium ion form कर रहा है और ये दूसरे तरीके से form कर रहा है, but ultimately the thing is the same, right? You are just going to get the aldehyde from the same mechanism. Yes, I hope it makes sense to you. If it does, please reply in the live chat कि समझ में आ रहा है कि नहीं. All right? Yes. Okay. Very well. Yes. Very good. All right, guys. Now, there is one more reaction which is very, very similar to this. Yes, guys. Very, very good. ठीक है, एक और reaction है which is very similar to this one. Let's consider that also. What is that reaction? Moffat oxidation. It is Moffat oxidation. not very difficult and very similar. ठीक है guys, even if you don't remember, let's say the reaction you don't remember, लेकिन हम क्या याद कर सकते हैं, एटलीस्ट प्रोडक्ट को देखकर या फिर हम रिएजेंट को देखकर कुछ रिएक्शन बनाना वो जरूरी है. So let's say you have DCC and DMSO. This combination, what is DCC? Dicyclohexyl carbodiimide. Alright, there's a cyclohexyl over here. If you want, you can draw, or otherwise you can just write the CY, cyclohexyl. Okay. So dicyclohexyl carbodiimide and DMSO. This is what you are going to have. Alright. In this is also just one step reaction. ये सिर्फ one step reaction है, which is a benefit of the Moffatt oxidation as compared to the Swern oxidation. देखो, very simple. Let's quickly do this. Alright, so what is happening, guys? Yes, we also have a little bit of acid. Okay, so let's look at the mechanism. Going to get RCHO only. जल्दी से देखते हैं mechanism, guys. So your dicyclohexyl carbodiimide molecule. Yes, this one. What does it do? In the presence of acid, first of all, in the presence of acid, this nitrogen is having a lone pair, this nitrogen is having a lone pair. So now it attacks on a proton, gets a positive charge over here. Alright, after that, when it gets a positive charge, ये carbon पे positive charge आ जाएगा because the electron density falls like this. Yes. Who is going to attack on the carbon? Absolutely the oxygen of DMSO. Okay guys, so whenever you are seeing some different reagent possibility, पहले ये check करना कि can the reagents react within themselves? If yes, then definitely the reaction can proceed that way. Alright, this is what you have. अब क्या कर सकते हैं guys? Positive charge on sulfur. Yes. Finally got a positive charge on sulfur. वही हमें वहाँ मिल रहा था in the Swern oxidation. It was just chlorine over here, which was a good leaving group. So कोई बात नहीं. This oxygen is also a good leaving group. Let's see how. अगर ये वाला आपका alcohol जो है, if this alcohol attacks RCH2OH, let's say if this alcohol attacks over here, so this oxygen is also a good leaving group, isn't it? ये देखो ऐसे करके. Yes. So what is the role of DCC, guys? जैसे yes, what is the role of DCC? To eliminate dicyclohexyl urea, to remove this oxygen from DMS and to help in the generation of the similar sulfonium cation. ये देखो, ये वही चीज बन गई guys. Exactly the same thing. This is exactly the same thing that we have got from the previous reactions. Yes, from the previous reaction, from the Korekim oxidation and from the Swern oxidation. ये वही की वही चीज मिल गई है. Isn't it? Yes. Alright. So I hope that till now it makes sense to everyone. Yes. Yes, absolutely. Now what happens is guys, अब हम प्रोटॉन हमें बेस की जरूरत है, बट मैम यू आर सेइंग कि ये तो एक स्टेप रिएक्शन है, वी आर नॉट गोइंग टू ऐड एनी बेस ओवर हियर. So what are we going to have? We have added HCl, for example. Let's say हमने HCl add किया है. So the proton is already used up and we have so many Cl minus in the mixture. We have so many Cl minus in the mixture that it can remove a proton from here and it can generate the same intermediate that we have actually got from the base CH2 minus. So the proton is removed internally within the reaction. RCHO. Okay, you're having RCHO and along with that you have DMS. और क्या byproduct है guys? Dicyclohexyl urea. So these are the byproducts. Okay, very important, all of you, byproducts of this particular reaction, Moffatt oxidation. Yes, बहुत ही अच्छा reaction है guys ये. all of these reactions are similar to each other. That is why I am making you study these oxidizing agents all together. ठीक है, ऐसे तो बहुत सारे oxidizing agents हैं. We have just seen one. We have just seen the application of how DMSO can do the oxidation. Okay, DMSO कोई oxidizing agent तो है नहीं. तो ये कैसे काम करता है? In the presence of a base it works, right? चलो, now we look at actual oxidizing agents, जो कि जिनके पास एक extra oxygen है which it can relieve. For example, very popular is, let's look at another reagent, guys. Today's fourth reaction for today is tetrapropyl ammonium perruthenate. बहुत लंबा नाम है, so let's write the shortcut TPAP. Yes, tetrapropyl ammonium perruthenate. Okay, so also known as TPAP. What does it do, guys? ये एक chemoselective oxidizing agent है. Chemoselective oxidizing agent. Okay, what is chemoselective? That is, in the presence of other groups, it is going to oxidize only one single group. ठीक है. So what is the role of chemoselective molecules? ये देखते हैं, guys. First of all, let's see what is this molecule. So tetrapropyl ammonium is nothing but PR4 propyl group. Tetrapropyl ammonium is going to look like this. And on the other side you have perruthenate, मतलब कि RuO4 minus. This is your oxidizing agent. ठीक है. और ये क्या करता है? It is a stable oxidizing agent for the conversion of primary to oxidize the primary and secondary alcohols. ठीक है. Obviously tertiary alcohol तो oxidize होगा नहीं, right? So only primary and secondary alcohols. How does it oxidize? Yes, देखो, is it very similar to osmium tetraoxide? Yes, looks like that कि वो भी OSO4 होता है, but it is RuO4 minus. That is one less oxidation state from that, and you are using NMO as a co-oxidant. As a co-oxidant, you are using the N-methyl morpholine oxide. ठीक है? Yes. ये तस्नीम देखो, बहुत सिंपल सा है. टेट्राप्रोपाइल अमोनियम पररूथनेट. This is the reagent. If you ever see this reagent, you are not going to think about any organometallic reaction. Metal तो है, कार्बिन वार्बिन कुछ नहीं बन रही है. It is oxidizing agent. And let's see how does it work. Yes, ये देखो, it is so important, guys. Look at this. हमारे पास epoxide है. OTBS. Let's say this is a protected alcohol, OTBS. And let's say this is a free alcohol. तो अगर हम इसी मॉलिक्यूल के अंदर PCC ऑक्सीडेशन यूज करते हैं, let's say we are doing PCC oxidation. So you must have seen some question, guys, where the PCC or the PDC oxidation are giving you side products through ene reaction or through any other reaction. तो वहाँ बहुत सारे side products बनते हैं. That is why we won't use PCC because the epoxide is a acid sensitive group. ऐसे वाले sensitive group के लिए हम PCC use नहीं करेंगे. We will use TPAP only. It is a chemoselective agent and so much selective, you see that the epoxide is going to be as it is. Epoxide को कुछ नहीं हो रहा है. Yes, the epoxide is as it is and you are just going to convert this alcohol into a into an aldehyde. So it is a very very important oxidizing agent, guys, isn't it? Yes, 1 degree alcohol को भी aldehyde में convert किया है, not acid. It is a mild oxidizing agent. It is less reactive, highly selective for any oxidizing or any reagent specifically. तो कोई भी reagent in general अगर कम reactive है तो वो ज़्यादा selective होगा. Less reactive and more selective. Less reactive and more selective. All right? Yes. Very, very, very important. Let's look at few more examples, isn't it? TPAP के example देखते हैं guys. Yes. Let's say if it is asked in the exam, so we must be able to say what does it do. So let's say I'm writing over here example number 1 for this case. Dichloromethane or methyl cyanide या nitrile, whichever you want to take as a solvent. ठीक है. So yes guys, what is happening over here? ये देखो, very very important molecule this is. आपके पास दो alcohol है. Yes, you are having one tertiary alcohol, another is a primary alcohol. So you can obviously say which is going to be converted into the aldehyde, isn't it? Yes. कौन सा convert होगा? You can say that easily. Absolutely primary, because this one does not have a proton to lose. All right. ठीक है. चलो, let's say we have done the oxidation, primary oxidation करा दिया. So it is like this. It is like this. Aldehyde बन गया. So what is this keep up going to do now? इसका काम तो हो गया. It has oxidized this group. Is it over yet? Or you can see one more possibility that the alcohol could attack over this aldehyde. Is it a possibility? There is, absolutely. Yes, बिल्कुल है possibility. So this OH was above. So what happens now guys? अभी ये एक spiro type का ring बनेगा. Yes, spiro ring is going to form. This part of the ring is as it is. इसको यहाँ ले आए, and you are having an oxygen already connected in this way. Alright, so first of all you will have a lactol, because if the OH attacks, this bond opens up over here, you are going to get a lactol. ठीक है. Lactol on further oxidation with TPAP will finally give you a lactone. In this way. Alright. So this is our final product. This is the final lactone that you are having. So basically it is just going to convert the primary and secondary alcohol into their corresponding oxidized state, only aldehyde and ketone, not the acid. It's not going to give you the acid. Alright. So guys, we are going to study two more important oxidizing agent. उनका क्या नाम है? एक तो हम पढ़ेंगे activated manganese dioxide, and the other one is Fattison's reagent, और उसको it is basically just silver carbonate on cellite. ठीक है. Two more important oxidation states, oxidizing agents we are going to see. ठीक है. चलो. Alright, let's take in the next page only. Activated manganese dioxide, MnO2. अच्छा बताओ, what is the oxidation state of manganese in this? Yes. What is the oxidation state of manganese in this? Yes. +4. Absolutely +4. Acha. So what was with KMnO4? KMnO4 के लिए क्या था? KMnO4 was +7, isn't it? KMnO4 के लिए +7 था. So which is a stronger oxidizing agent? KMnO2 या फिर KMnO4? Definitely यही है. Stronger oxidizing agents. So for those oxidizing agents which are stronger, they are going to be less selective, isn't it? So this is a strong oxidizing agent, yeah, stronger oxidizing agent and less selective. All right, so KMnO4 in the presence of an alkali is going to give you diol from the alkene, you know that already. ठीक है, and it might break the alkene in the presence of acid or in the neutral condition. Neutral condition में alkene से क्या मिल जाएगा? Two different ketones. Okay, or an aldehyde or a ketone respectively, whatever the alkene is like. ठीक है, so this is more reactive and less selective. However, activated manganese dioxide का क्या काम है guys? ये तो selective oxidation ही देता है. It also gives you selective oxidation. So that is very, very important about this particular reagent. Gives you selective oxidation. Yes. चलो फिर. So highly chemoselective. It is highly chemoselective, that is your activated molecule. What does it do? मेरे पास दो alcohols है, let's say. I have two alcohols. I am having the alcohol and the acetone as a solvent and MnO2. मेरे पास ये सारी चीजें हैं. So which alcohol is going to be oxidized in this particular molecule? In this way, isn't it? Yes. All right. So we have written down first example, guys. Let's also write down another example. Let's see. Yes, absolutely. Benzylic position is going to be more reactive in this particular reagent. Highly, highly chemoselective. Very, very important. Okay. Yes, Meena. Same reactant agar reacts with PCC, what is the product? PCC will first give you preference of oxidation of this one, but then it is going to oxidize both. अगर आप one equivalent use कर रहे हो, one equivalent of PCC if you are using, it will oxidize this one primary alcohol first and convert it into aldehyde. Okay, because it is more available and easily more reactive, right? So absolutely इसको पहले oxidize करेगा PCC, and when you are taking excess it will oxidize both. All right. All right. So the double bond is as it is, guys. ये वाला जो double bond है, ये as it is रहने वाला है into this system, and you might get the oxidation. अच्छा, just one second, sorry. ये मैंने homoallylic alcohol बनाया है. It is not allylic alcohol. Yes. What is the difference? ये देखो, what is the difference? If this oxygen was over here, then it would be the allylic oxygen, allylic alcohol. लेकिन फिर ये tertiary allylic हो जाएगा, so there is no oxidation. Now, if it is one carbon away, it is homoallylic oxygen, homoallylic alcohol. और ये वाला फिर से is a benzyl alcohol, isn't it? Yes. So benzyl alcohol is going to be oxidized to give you a CHO. Absolutely. Yes. All right. So basically, guys, MnO2 का आपने क्या समझ में आया? Basically, MnO2 is going to oxidize. It is going to oxidize the allylic and benzylic OH, preferably over other groups. All right. Yes, it does. तो इसका मतलब ये थोड़ी ना that it will never oxidize the simple primary alcohol या फिर सिर्फ इन्हीं को oxidize करेगा. No guys, that doesn't happen. Let's say हमारे पास एक ये molecule है. All right. So this is first converted into the aldehyde. Yes. और second step में you are having a stable ylide. तो क्या होना है फिर? This is going to get converted into this molecule finally. ठीक है? Yes. All right. So this is your final product. So it is definitely going to oxidize the alcohols, लेकिन where there is a possibility, जहाँ ये present है already, तो ये selectivity इसकी increase हो जाएगी for the allylic as well as the benzylic OH. Just that. Okay? Yes. Chalo. So we move onwards, guys, and we study our last oxidizing agent for today. And what is that? वो यहाँ पे Fetison's reagent. Alright, Fetison's reagent. Bock protecting group. Yes, Bhakti. Bock protecting group is. अच्छा, you are asking कि अगर हम protect कर दे तो something like that. Okay, please elaborate a little bit. All right. Okay, chalo. So we were on the Fetison's reagent. Ag2CO3 and cellite. What is cellite, guys? Cellite is just another aluminosilicate, just like zeolite. ठीक है, तो जैसा zeolite होता है वैसे ही cellite होता है, aluminosilicate. So it is taken as the base material in which the Fattison's reagent is going to react. Once again, it is a chemoselective reagent. So guys, अभी तक हमने ज़्यादातर chemoselectivity की ही बात करी है, because these are very very important. Chemoselective oxidation. Whose chemoselective oxidation? Yes, ये देखो, once again, chemoselective oxidation is going to be the same for this as well as MnO2. लेकिन ये देखो, it is going to also have preference. Allylic and benzylic are going to be the same preference, and then more preference for 2-degree alcohol than 1-degree alcohol. Okay. Once again, chemoselective oxidizing agent. ठीक है, तो अगर मेरे पास ये मॉलिक्यूल है, let's say OH, and this is another OH like this, Ag2CO3 and cellite, right? How is it going to give you the product? इसका product कैसे बनेगा? Yes, absolutely. The secondary group is going to oxidize. So, yes, preferred over the primary one. Secondary alcohol is oxidized. So, similarly, हम एक और molecule देख सकते हैं. Yes. So, same thing. Ag2O3 on cellite on this particular example. So, which alcohol will be oxidized, guys? Here we have a possibility of secondary as well as primary as well as allylic. So ये जो allylic alcohol है, this is going to be oxidized as it is. Yes, ये रहा secondary allylic alcohol. Okay, more preferred. Secondary allylic alcohol is more preferred. All right. Chalo. So guys, these are some really important reactions for the Fattigson's reagent. Once again, chemoselective oxidation है, right? और एक example देखते हैं. All right, just 1 second. I'll just have to erase a few things to see few more examples. Yes, चलो. Ag2CO3 and you have the cellite once again. ठीक है, benzene reflux, so you will have some solvent और फिर reflux करेंगे. तो देखो guys, what is going to happen? You have two alcohols. This is another primary alcohol. ये भी primary है, but this is primary allylic. So you will say कि मैम इसको oxidize कर दो, which is actually the case. चलो ठीक है, this is going to be oxidized. But is it going to undergo any further reaction? Yes. Okay. cyclization in this way. So after cyclization, you will first get the lactol. Lactol मतलब कि इस तरीके से alcohol बनेगा पहले, which will be further oxidized in this case. All right. So yes, this is your final product. Okay. All right, guys. So अभी देखो guys, we have plenty of different sessions. We will be doing previous year questions also. तो आज नहीं करेंगे previous year question. We will do previous year questions once we have studied a little bit. थोड़े से और next session में करेंगे. And yes, guys, all the important reagents we have studied on oxidizing, all the chemoselective agents we have studied, Fetison's reagent, MnO2, TPAP oxidation, Swan, Moffat and Korekim oxidation, बहुत ही ज़्यादा important है ये सारे के सारे, right? And once again reminding you all कि अगर आपने mock test में enroll नहीं किया है तो please enroll over here. It is very very important that you do and give the mock test on 28th of August. All right. Yes, and in few minutes I'm going to see you all in the Unacademy Plus session 10:30 a.m. को organometallic session है आज, right? So yes, guys, also join the Telegram group for daily notifications about the important classes, all the important classes. ठीक है? Yes. Okay. All right. Yes. ये देखो. What is, yes, Har Har Mahadev, you're asking what's the nature of allylic alcohol? Allylic alcohol is polite, which you are not. Okay, और आपके जैसे लोग ना महादेव का नाम खराब करते हैं, सो ना बिना मतलब की ऐसे क्लास में मत घुसा करो. ओके, जहाँ पे आपको पढ़ना नहीं हो और टाइम खराब करवाना हो. Alright guys, so we'll see you all at 10:30. Bye everyone. Take care all of you.